Our last section of Chapter 3 is called Measures of Position. There are two different measures of positions, quartiles and percentiles. Quart stands for 4. So this is where we're going to divide our data into 4 equal groups. Percent refers to 100. So that's when we're comparing ourselves to 100% of the people who took whatever assessment it is we're talking about. Alright, we've got a few instructions here. We're going to find a 5-number summary, construct a box and whisker plot, and then we're going to find an IQR and test for outliers. Well, our 5-number summary is listed down below. We know what a minimum is, we know what a maximum is, we know what a median is. So the median cuts our data in half. Well, if we cut the lower half of our data in half, that's where we get quartile 1. So we cut it into 2/4. And quartile 3 cuts the upper part of our data into 2/4. So we already get those numbers on the calculator. It's very easy for us to just write them down, but if you're watching the video, I'm going to show you kind of how this works. The first thing it says we need to put the data in order, because if we're going to find the median by hand and the minimum and maximum, it helps if our data is in order. So here's the same data, only it's in order. Here's our minimum is 5, it's our lowest number, and our maximum is 37. Now if we were going to do this by hand, we would find the middle number first. The middle number is this 15. That's our median. Now how do I know? Just count. Our median cuts our data in half. How many data items do we have over here? How many data items do we have over there? So we got 7 on each side. The median cuts our data in half. Now if we look just at this lower half, just at everything below 15, if I looked at that as a data set by itself, that number 10 would cut that lower half in half. 3 on each side of it. So 10 is our first quartile, because it cuts the lower half into half. Half of half is a fourth. Over here, same thing. If we find the middle number for the upper half of the data, 3 data items to each side, that'll be our third quartile. Now what I want to do is use that to construct what we call a box and whisker plot. To construct a box and whisker plot, we have to first have a number line. The number line doesn't get our graph. The number line is going to be a ruler so that we make our graph. All the pieces and parts are proportionate. So I went from 5 to 37 from my minimum to my maximum, so I decided to count by 5s on my number line. Above my number line, I need to start at 5 and go to approximately 37 to make my whisker. The whisker part of the box and whisker plot spans the entire range of the data, so from 5 to 37. The box goes from Q to Q, so it's going to go from 10 to 18. It's going to be centered on the whisker, not sitting on top of it or hanging from it. And the median is going to split the box into 2 pieces, not necessarily equal pieces, just 2 pieces. So I have the same number of data items there, there, and there. Those are my 4 regions. This area holds the same number of data items as this area, which means that in this area, those data items have to be a lot closer together than the same data items that would fall out here. So when we talk about measures of position, that's what we're talking about, is how clumped up or separated each set of data or each region of data items would be. So that I made a prettier box and whisker plot instead of by hand. That region holds the same number of data items as that region, and that region, and the last one. So each one of those regions holds 25% of the data, whether that would be 3 data items or 100. So where do the data items fall the most closely together? That would be in the region that takes up the less room. So 1, 2, 3, that would be quartile 3. Where is it most spread out? That would be this big old long whisker. So that's quartile 4. The box has 25% of the data here and 25% of the data here. So the box represents half your data, 50% of it. And which half? Well, I've got a fourth that's lower and a fourth that's higher, so it's the middle 50% of your data. The range, now that's a vocabulary word from before, and just because it's a vocabulary word from before doesn't mean how we find it changes. The range is the maximum minus the minimum, so the range is 32. Now the interquartile range is the range of the box, the range of the middle 50% of your data. So that would be not the minimum minus the maximum, but the bigger part of the box minus the smaller part of the box. So 18 minus 10, the IQR is 18. The IQR is 8. Sorry about that. Went a little crazy. 18 minus 10 is 8. Now, if I want to test for outliers, I have to do a thing called finding the fences. There's 2 formulas, one for the lower fence, one for the upper fence. The lower fence means I'm going to check for outliers that way. So I start at the low end of the box, which is Q1, and then to go left of the box, the operation is subtraction. That's how I go left on a number line. And the amount I'm going to go left is 1.5 times the IQR. So for us, Q1 was 10 minus 1.5 times the IQR was 8. 10 minus 1.5 eighths, is that negative 2? I think it is. Negative 2 or negative 4. Let's see. 10 minus 1.5 times 8 is negative 2. So what that means is if I had any data values smaller than negative 2, that would be an outlier. Now, if you look at the picture, it doesn't really look like I would have outliers over here. But when you've got this big old long whisker, that's another language. When you got this big old long whisker coming out here, that looks like there might be a potential for outliers. So if I want to check for outliers out there toward the right, then what I do is I'm going to start at the right hand side of the box. That's why it changed to Q3. Plus is how I go that way on the number line, and the distance is again 1.5 IQRs. So I start at 18, and I'm going to go up 1.5 times 8, which is 30. That means anything that goes past 30 is an outlier. If I had a data value that was 30 exactly, that would not be an outlier. That would be fine. But anything higher than 30 is an outlier, which means that 37 is an outlier. Percentiles? Percentiles tell you ranking. They do not tell you scores. So if you make a 30 on the ACT and that puts you in the 95th percentile, what that means is you did better than 95% of the people who took the test. It says nothing about how many problems you actually got right or wrong. 1100 on an SAT puts you in the 64th percentile. That means you did better than 64% of the people. You did worse than 36%. Now to tie this in with what we just did, the 50th percentile, that would be your median. Half are better, half are worse. 25th percentile means you're better than 25%, worse than 75%. That would be the first quartile. 75th percentile means you are higher than 75%, less than 25%. That would be your third quartile.